Alright, this is the second part of 2.5. It's on quadratics. We're going to look at the square root method, which says if we have x squared is equal to some number p, then we can take the square root of both sides and x will be equal to plus or minus the square root of p. We can generalize that to be an expression squared equals p. Then we can take the square root of both sides, and then we have expression is equal to plus or minus the square root of p. And I'll give you kind of an explanation in a minute with the first problem, why we need that plus and minus there. Okay, so we're going to go ahead and solve using the square root method, and we're going to have x squared is equal to 64. So we're going to undo the squares. We're going to take the square root of both sides, and don't forget your plus and minus. So x is going to be equal to plus and minus 8. If we were to solve this a different way, if we wanted to solve by factoring, we would subtract 64 and then factor that into x minus 8 and x plus 8, and that would give us the two solutions of plus and minus 8 there. Okay, so that is why we want the plus and minus there. Okay, so we're going to run through a couple more examples, and so one of the things that we'll want to do is we'll want to isolate the quantity squared. So for example, in this one here, we have 6x squared minus 150 is equal to 0. So what we'll want to do here is isolate the x squared. So we're going to add 150 to both sides. And once we've done that, we'll divide by 6 and then take the square root of both sides. Okay, so then divide both sides by 6, and we get x squared is equal to 25. Take the square root, don't forget your plus or minus. X is equal to plus and minus 5. Okay. This one we could have solved by factoring also, but we're practicing the square root method or property. Okay. This one here, we're going to have an expression x minus 1 squared equals 25. So that falls into the second category here. We can still solve it in a similar fashion. We'll go ahead and take the square root of both sides. And don't forget your plus or minus on the 25. So you only need the plus or minus on one side of the equation. You don't need it on both. And so we're going to get x minus 1 is equal to 5, or x minus 1 is equal to negative 5. And that's from that plus or minus. So we need to split it up into two equations. We're not going to get plus or minus 6. You got to be a little bit careful there. So we have x is equal to 6, or x is equal to negative 4 there. Okay, the next problem we're going to do twice, and it is dependent on what the instructions are asking. So if they're asking for real solutions, what's going to happen in this problem is we're going to take a square root of a negative, which will give us imaginary numbers. If they ask only for real solutions, we're getting imaginary numbers, so we're going to say that's a no solution. And if you're using MyOpenMath or Lumen, you'll just, I think they want you to write D and E. Okay. If they ask for real or complex solutions, then we can go ahead and simplify that square root of negative 18. So you have your quantity x plus 2 squared equals negative 18. We'll take the square root of both sides. Don't forget your plus and minus. The square and the square root will undo each other. And then we'll go ahead and write negative 18 as 9 times negative 1 times 2, so that'll help simplify the square root. So plus or minus 9 times negative 1 times 2. X plus 2 is equal to, we forgot our plus or minus. Don't forget your plus or minus. So x plus 2 is equal to plus and minus 3i. 3i root 2, and so that would be your two separate equations there. In both cases, we'll subtract 2, and we get x is equal to negative 2 plus and minus 3i root 2. Okay, so if we finish solving these, that would be your two distinct answer if they asked over the complex numbers. Okay. The next thing we're going to look at is called completing the squares. We'll do a little bit of that in this class. We'll do it a lot more in pre-cal. I don't remember if we have it in Cal 1, but we have some places in Cal 2 and Cal 3 where we use it. So we'll do a couple examples of this. And So I'm going to write down kind of the guidelines to do it, and then we'll work through a problem simultaneously as we're walking through the steps. So the goal is to construct a perfect squared trinomial. So we're going to rig this to work out correctly. So we'll start with standard form ax squared plus bx plus c equals to 0. And the first thing we will do is we'll identify our ABCs. We'll also do that with a quadratic formula. So problem number 15 from the notes is 4x squared minus 3x minus 9. A is 4, B is negative 3, and C is negative 9. So we've identified our ABCs. So now that we've identified our ABCs, the next step we're going to do is we're going to move C to the other side of the equation. So we're going to move the C. So we're going to add 9 to both sides. 4x squared minus 3x, and that's going to be equal to 9. The next thing we're going to do is we're going to divide both sides by a. If the a is 1, we won't need to do that step, but in problem number 15, the a is 4. So we're going to divide everything by 4. And so this is to rig it to get a perfect square trinomial. So x squared minus 3/4 x is equal to 9 over 4. Step 4, we're going to add b over 2a squared to both sides. And that's going to rig it so it factors nicely. So in this case, that's negative 3 over 2 times 4 quantity squared. So that's negative 3 over 8 quantity squared. And 9 over 64. Now, the way we've set it up is this thing, after we've added that 9 over 64, is going to factor into x minus 3 over 8 quantity squared. So once you find that b over 2a, that's how it's going to be set up to factor nicely. Okay. So we're going to add that 9 over 64 to both sides. So add it to both sides. Okay, and then the next thing to do is to factor and simplify. So we have x minus 3 over 8 quantity squared is going to be equal to, and then we're going to have to get a common denominator over here. So the common denominator between 4 and 64 is 16. So we're going to multiply the top and the bottom of 9 over 4 by 16 so that we have those common denominators. 9 times 16 is 144, and then we have the plus 9 all over 64. The last step to do is to solve using the square root property or method, however the book refers to it. So you have x minus 3 over 8 quantity squared is equal to 153 over 64. We'll go ahead and take the square root. Don't forget your plus or minus. X minus 3 over 8 is equal to, and we had to work with 153 for a little bit, so 153 is going to be 9 times 17 all over the square root of 64 is 8. Okay. Then we're going to add 3 over 8 to both sides. So there's the 3, and then we'll have an 8 on the bottom here. Okay, so there's your adding your 3 over 8. And then plus or minus, the square root of 9 is 3, and then the square roots of 17 all over 8. Okay. And then if we need to put in separate answers, that's 3 plus 3 root 17 over 8, and 3 minus 3 root 17 all over 8. Okay. So we're going to run through another example here, and then we'll do an application of completing the square. Okay. So number 16, we have x squared minus 8x minus 4 is equal to 0. We'll identify our ABCs. So since it's just an x squared, the a is the coefficient on the x squared, it's 1. The b is negative 8. And the c is minus 4. The next thing we're going to do is we're going to move c's. We're going to add 4 to both sides. So we have x squared minus 8x is equal to 4. Okay, because the a is equal to 1, we don't really need to divide both sides of the equation by a, so we can skip that step in the completing the square. And then the next thing we're going to do is we're going to add, sorry, I got this confused with the vertex form. It's just b over 2a, not negative b over 2a, so let's take that off. Okay, so we're going to add b over 2a to both sides. Okay, and so It's going to be negative 8 over 2 times 1 quantity squared, which is going to be, it should be negative 4, excuse me, negative 4, oops. Negative 4 squared, okay? And so that's what this is going to factor into, x minus 4 quantity squared when we're all done after we add 16 to both sides of the equation. Okay. So we're going to add 16 to both sides. So add 16 here, add 16 here. So the left-hand side is perfect square, is factor into x minus 4. The right-hand side is 20. 20 is 4 times 5. Take the square root of both sides. Don't forget your plus or minus. X minus 4 is equal to plus or minus 4 times 5. Add 4 to both sides. And the square root of 4 is 2. And we don't know what the square root of 5 is. So you notice that I didn't separate it into two equations. X minus 4 equals 2 root 5, and then x minus 4 equals negative 2 root 5. The reason being is the 4 and the 2 root 5, they're not like terms, so I don't have to worry about having two separate equations. I can if I want to, but it's not necessary. Okay. And then we can split it up into the two separate equations, 4 plus, or I'm sorry, the two separate answers, 4 plus 2 root 5 and 4 minus 2 root 5. Okay. The next one we're looking at is an application of the complete the square. So we'll start generically. Ax squared plus bx plus c equals 0. First thing we're going to do is going to move c, so we're going to subtract c from both sides. So ax squared plus bx is equal to negative c. The next thing we'll do is we'll divide everything by a. So ax squared divided by a is x squared plus b over ax, and that's going to be equal to negative c over a. The next thing we're going to do is we're going to add b over 2a squared to both sides. Okay. And what b over 2a squared is b squared over 4a squared, and if we grab that minus c over a, what this is missing to get a common denominator is we need to multiply it by a 4a and a 4a. Okay, so we're going to get a common denominator over there. The way we've constructed this is the left-hand side is going to factor into x plus b over 2a squared. And that's going to be equal to negative b squared. I'm sorry, positive b squared, excuse me. And then we're going to get a common denominator. And then minus 4ac all over 4a squared. We'll go ahead and take the square root of both sides, and don't forget your plus or minus. So plus or minus square root of b squared minus 4ac. And then square root of 4 is 2, square root of a squared is a. And so then we will subtract b over 2a, and then you get x is equal to a negative boy who's uncertain whether he wants to go to a radical party. Because he's a square, he misses out on 4 awesome chicks, and the party is all over at 2 a.m., but there's no m in the formula. So that's your quadratic formula. X is equal to opposite of b plus or minus square root b squared minus 4ac all over 2a. So to get to the quadratic formula, we have to do completing the square. So one of the consequences is both completing the square and quadratic formula will solve any quadratic equation. Okay. All right. So here's a quadratic formula here, and then we also have something called the discriminant. That's the b squared minus 4ac. That's the thing under the square root. That is going to tell us what kind of answers we're going to have. So we have 4 conditions. If b squared minus 4ac is greater than 0 or positive, and it's a perfect square, then you're going to have 2 different rational roots or solutions, however you want to describe that. Roots or zeros, answers, all the same thing. If b squared minus 4ac is greater than 0 or positive and not a perfect square, then you're going to have two different irrational roots. So you're going to end up something like, square root of 17 that you can't simplify down. So that's going to be irrational. If b squared minus 4ac is equal to 0, then you're going to have one rational root of multiplicity 2. Sometimes that's called a repeated root, or it could be called a double root also. And then finally, if b squared minus 4ac is less than 0 or negative, then you're going to have two complex conjugate roots because you're going to be taking the square root of a negative. So what complex roots look like is a plus bi, and the conjugate would be a minus bi. So the a and the b would be the same, but you would have the opposite signs for your conjugates there. Okay, so we're going to run through, I think, 4 examples, and then we'll kind of hit each one of these 4 possibilities here, running through the quadratic formula. I'm going to do it a little bit different where I find the discriminant of each one of these. You can do it that way. You can just throw it all into the quadratic formula. It's kind of up to you. But if I do the discriminant, that allows me to identify what kind of answers I have fairly quickly. Okay, so we're going to solve using the quadratic formula. You can remember my silly story about the negative boy. I think there's you're going to have to find a YouTube video where they sing the quadratic formula to Pop Goes the Weasel, or just make a flashcard or something like that. But one way to help yourself is every time you use the quadratic formula, go ahead and write it down to help memorize it. Okay, so we're going to look at 4x squared plus 9x minus 9 equals to 0. We'll identify our ABCs. I'm going to find the discriminant of b squared minus 4ac. So it's going to be 9 squared minus 4 times 9. So it's going to be 81 plus 144. Which is 225, which happens to be 15 square. So that is a positive, and it's a perfect square, so that's going to tell us we're going to have two different rational roots. Okay? Write down the quadratic formula. X is equal to opposite b plus or minus square root b squared minus 4ac all over 2a. Opposite b will be negative 9 plus or minus. We already found the discriminant. It's 15 squared all over 2 times 4. So our two answers are negative 9 plus 15 over 8, which is going to be 6 over 8, which reduces to 3 over 4. So there's a rational, or negative 9 minus 15 over 8, negative 24 over 8, and that's equal to negative 3. That is also a rational number, and they are not the same. Those are two different rational roots. Okay, let's take a look at another one. 2x squared plus 12x plus 18 equals 0. We do have a greatest common factor, so if we have a GCF, then we can divide everything by 2. That just makes the problem easier. And divide everything by 2. X squared plus 6x plus 9 is equal to 0. Identify your ABCs. Because we only have an x squared, the coefficient there is 1. 1, 6, and 9 are your coefficients. Find your discriminant, b squared minus 4ac. 6 squared minus 4 times 1 times 9. Okay? So we'll go ahead and crunch those numbers. That's going to be 36 minus 36, which is equal to 0. So if we had the discriminant was 0, that meant we had one repeated rational number solution, or root of multiplicity 2. Okay, so a couple of different ways to say that. So we'll say one rational root, and we can say it's a repeated root. Quadratic formula, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So negative 6 plus or minus square root of 0 over 2 times 1. The square root of 0 is 0, so essentially what we have is negative 6 over 2, or negative 3, and that's our double root there. Now had we solved this equation by factoring, you would have had x plus 3 squared equals 0. And that square there would give us the repeated root there. and the root of that polynomial is -3. Okay, I think we got 2 more, and then that'll wrap this video up here. So 19 is 2x squared plus 2x minus 5. There is no GCF. Identify your ABCs. 2, 2, and minus 5. Find the discriminant, b squared minus 4ac. 2 squared minus 4 times 2 times 5. Negative 5, excuse me. So it's going to be 4 plus 40, which is 44. 44 is not a perfect square. It is positive, so we're going to have 2 different irrational roots. And 44 is 4 times 11, so we might want to write it that way when we stick it into the quadratic formula. Okay, so 2 irrational roots, or you can say they're different if you like. Okay, and 44 is 4 times 11. That'll help with simplification. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So negative 2 plus or minus 4 times 11 under the square root all over 2 times 2. Negative 2 plus or minus the square root of 4 is 2. We don't know what the square root of 11 is. All over 4. We can reduce everything by 2. So we will have negative 1 plus or minus square root of 11 over 2. You can say 1 square root is 11 if you want to, over 2. Okay. All right, and one more. All right, so last one. 3x squared plus x plus 10 is equal to 0. Identify your ABCs, 3, 1, and 10. Discriminant, b squared minus 4ac. 1 squared minus 4 times 3 times 10. And that's going to be 1 minus 120, which is negative 119. And I think that's going to be a prime, so I don't think we're going to be able to simplify that down. It is negative, so that's going to tell us we're going to have 2 complex conjugate roots. And we'll write that as negative 1 times 119 just to help us with the quadratic formula. Alright, so x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So negative 1 plus or minus negative 1 times 119 under the square root all over 2 times 3. Negative 1 plus or minus square root of negative 1 is I, and then root 19 all over 6, and that's about it. Okay, if you check my YouTube video for YouTube channel, there is a playlist for Unit 1, so I think there's probably some more examples of quadratic formula and completing the square. And some of you have mentioned that Khan Academy has some good stuff too, so I'd check out Khan Academy too if you want some more examples. I think it's on the homework assignments in My Open Math and Lumen. They have some videos too if you need some more examples. Also, you got the Open Stack. So if you need more examples, there's plenty out there.